Welcome to Summarize Science. Today we are looking at a major breakthrough in how robots learn to interact with the world through touch. Simulating the physical world is incredibly difficult, especially when multiple objects are bumping into each other at once. For a long time, the software that powers these robots has been limited by a slow process called contact resolution. When a robotic hand touches a cube, the computer has to solve a massive mathematical puzzle to figure out exactly how it should react. The problem is that as the task gets more complex, the time it takes to solve that puzzle grows exponentially. The researchers behind this paper have introduced ComFree-Sim, a new engine designed to bypass these slow calculations. Instead of solving puzzles through trial and error, ComFree-Sim uses analytical math to find the answers in one go. This allows the engine to be 2 to 3 times faster than current industry standards. This speed comes from something called complementarity-free modeling. It treats contact forces like a predictable flow rather than a series of rigid constraints. Because the math is simpler, it maps perfectly to modern graphics cards, or GPUs, which can handle thousands of these tasks at the same time. The engine doesn't just look at simple impacts, it uses a unified 6D model. This means it can simulate sliding, twisting, and even the way a cylinder rolls across a table with high accuracy. It uses a prediction and correction method to ensure objects don't ghost through each other during fast movements. In testing, the team dropped hundreds of small shapes into a pile to see how the software would hold up. ComFree-Sim proved to be both stable and realistic, maintaining its speed even as the number of contacts skyrocketed. This efficiency is what allows the system to be used for real-time control of actual hardware. They demonstrated this by putting the engine to work on a real-world multi-fingered leap hand. Because the simulation was so fast, the robot could plan its next move 72 times every second. This high-frequency control resulted in significantly higher success rates for rotating complex objects. They also applied the technology to humanoid robots to help them perform agile tasks like dancing and martial arts. By simulating the physics of balance and impact so quickly, the robot can retarget complex motions while remaining stable. This shows that the engine is versatile enough for everything from fine finger movements to full-body athletics. To recap, the researchers have created a way to eliminate the mathematical bottlenecks that hold back robotic dexterity. By switching to analytical math and utilizing GPU power, they have made touch simulation faster and more reliable. This could lead to a future where robots can perform delicate chores or work in environments that require instant reflexes. The work on ComFree-Sim proves that smarter math is just as important as better hardware. As these engines continue to improve, we may see robots move from the lab into our homes with much greater ease. Thank you for watching Summarize Science.